tend to just go directly to that unit and just feel on it there because one's kind of stupid. But hey, that's just me. Doesn't mean that it really is. So, a few things I wanted to find. A couple things we're going to look at here today. Do you guys remember what that little directional arrow means when you have them on two consecutive lines like that? Parallel, very good. They're parallel. When you have those little arrows drawn on lines, these little directional arrows like this, they're not tick marks like we did with segments where we just throw a tick mark on there to show they're congruent. That means that those two lines are parallel. And when you have lines that are parallel, will those things ever intersect? No. Now, algebraically, do you guys remember the reason why they don't intersect? What do they share in common? Slope, good. Remember, parallel lines always share the same slope. That just means they're always going to be, if they're going up and to the right, the same amount, they're never going to touch, okay? So we have parallel lines. The other thing that's on here is this diagonal line I drew here. This is something new. You might have heard of it before. It's called a transversal. Transversal. I didn't know this. Do you guys know Mrs. Thrower? One of the other math teachers. She works with a lot with the inclusion classes and stuff. She's one of them. She actually was brought up back in her day. They did a lot of Latin. Latin was it does a lot of the original roots for words. And the Latin root for transversal is trans and then versal. Well, trans in the Latin root means across. Versal is cut. So transversal is to cut across. Like transatlantic goes across the Atlantic. Transcontinental goes across the continent. Things like that. That's what that means. Now, a transversal just means it cuts across two lines. Transversal is a line that cuts across two or more other lines. Okay? Excuse me. So a transversal is something that cuts across two or more other lines. More often than not, we're going to look at it in just two. It cuts through two lines. Every once in a while, you might see 3 or 4. It's no big deal. It's just how it works itself to be. Now, the other thing that we have done already last week, actually, is that when we had one line intersecting one other line, how many angles were formed? We had 4 angles that were formed. You guys remember that? We just labeled them 1, 2, 3, and 4. And with that intersection, we knew some information. We knew right away if we have angle 1, 2, 3, and 4. Give me 2 angles that are the same. 2 and 4 and 1 and 3. If 1 and 2 were the same, what would that transversal have to be? What angle would it have to be at? Vertical. It'd have to be vertical. It'd have to be at a 90-degree angle for those to be the same. Right? What happens here is you get the transversal cuts across one line, and you guys remember there was a definition called vertical angles. We had vertical angles that were congruent, and then we had angles that were next to each other that created a line. Those were called a linear pair. Right? So when you had the linear pair, angles 1 and 2 have to add up to equal how much? What will angles 1 and 2 have to add up to equal? 180. Good. Now we know that 1 and 2 are this. 1 and 2 have to be 180. 2 and 3 have to add up to 180. 3 and 4 have to add up to 180, and then 4 and 1 have to add up to equal 180. All right. Are 2 and 4 the same angle? Yeah, they're also vertical. So what we've done in the past is that we knew that this occurred. We knew that those angles across one another being vertical would always hold true. We also knew that if we had numerical value, let me get that over here. If we had some sort of a numerical value, if this was at 110 degrees, what does this have to be at?
70.
Oh, I was pointing at this one. That would be 70. Now this one would be, well, I thought you said 70. I was like, what? And then back to 70. We knew that's what that would look like, correct?
Yes.
Now, what happens here then, when we add this secondary line, as soon as that line is what we call parallel, these angles just repeat themselves down below. Okay? But now instead of having 4 angles, how many do we have? 8. So what I normally do is I just relabel them 5, 6, 7, and 8. And then I draw in my other, excuse me, I would start to draw in my tick mark stuff. This is where the vocab that we're going to look at today starts in. So when we have this, when we get what are called 2 parallel lines cut by a transversal, it's a whole bunch of words.
It's a lot of it.
It is. But there's a symbol for that, and we'll get to that here in a second. You wind up with repetitive angle placement. Do you guys agree that angle 1 is in the top left corner of those top 4?
Yeah.
Which angle is in the same position down below? 5. So when the angles are in the same position, if the lines are parallel, they're the same measure. What's in the same spot as 2? 6. So basically, instead of saying same position, what we say they are corresponding. Does that ring a bell?
Yes.
And then 3 and 7 would be the same. Again, notice that they're vertical, and then you have this one here as well. So what happens then is that as soon as we get this idea of whenever you have what we say, if 2 lines are cut by a transversal. Oh wait, I don't want to write all that out. That sucks. That's too many words. Guess what we do? There's a symbol for it. It's kind of an abbreviation. What we do instead of writing all of this out, because we say this a lot, there is a symbol that represents it. Just like you guys learned that in algebra, this stood for parallel lines. Those two next to each other meant parallel. Do you remember that? You did this. What did this mean? Perpendicular. Okay. In math, we do a ton of abbreviations for things. Parallel, we just use the slashes. Perpendicular, we do the upside down T. So here, instead of writing all of this out, we make the following symbol. That symbol represents if 2 parallel lines are cut by a transversal. Okay? That symbol represents that statement. And that's what this is going to look like. Instead of writing out all those words. Okay? So if this does happen, there are 4 angle pair relationships that occur. Okay, there's going to be 4 of them. And that's kind of what that pretest thing was looking to see if you knew any of them. You didn't, which is fine, because guess what we're going to learn? Yeah, you're going to learn how to do it. Well, a lot of times when they talk about the idea of the student growth portion for being a teacher, math kind of has it a little easy, because I can show you something you guys haven't done, and then all of a sudden teach you. Whereas most of you guys have written a paper, most of you guys have written some things, and it's kind of difficult to change your style of writing to learn something new about how to write. So that's a little bit more difficult to show the growth portion of it. Whereas in math, I can pick a specific standard, a specific thing that you haven't done, and then teach you, and then all of a sudden, you might learn it. So I hope you learn it, because it'll make everything great. 4 types. First one we'll look at is called corresponding. Corresponding angles, really super easy to work with. Corresponding angles are angles that are in the same spot on the same side of the line. Same spot on same side, bless you, of the transversal. Okay. What I mean by that is top right has to correspond to top right. Okay. In my diagram on the whiteboard, angle 2, angle 6 correspond to one another. Those corresponding angles are congruent. Top right, top right. That's what it means to be corresponding. You're in the same position. If you're in the bottom left, what would correspond to the bottom left? The bottom left of the other one. So if this angle here, oh, that's vertical, isn't it? Which means it's this one. Huh, look at that. Same position, same side of that transversal. That transversal is the one that cuts through. Same position, same side. Those guys will always be equal. Go back to my numerical one here. Top left here is 110. Isn't top left here also? 110. Convenient, isn't it?
Yes.
They correspond. I know, this is groundbreaking, earth-shattering craziness here today. Okay? There's our first one, corresponding. Next one, we call alternate interior angles. Okay? Alternate interior angles. Parallel lines, got my transversal. Alternate interior, well, when things alternate, they switch, don't they?
Yes.
Okay. Well, in this case, we're switching. Interior means inside. So I'm switching inside, which means they are angles on opposite sides of the transversal. Inside the lines. Opposite side and inside. There are opposite sides on the inside. If I look at my picture, 4 and 6, 3 and 5. Opposite side, inside. Alternate interior. Okay? Those guys are also congruent. Opposite side, inside. We use alternate interior all the time with these types of pictures and diagrams. There are 2 sets of alternate interior because there are 2 sets of interior angles. Again, our example here, 4 and 6 are the same. 3 and 5 would be the same. If you look at our numerical value over there, 70 and 70, see how they're on opposite sides on the inside? 110 and 110, opposite side, inside. If there is alternate interior, guess what else there is? You guys are SMRT.
Wait.
Ding, 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 ding. Okay. When you're dealing with alternate exterior, same deal. Opposite sides, but now they are on the outside. These are angles on opposite sides, oops, of the transversal on the outside. So if I'm looking at top left, the alternate outside would be bottom right. Think of the position again. Top left, alternate would be bottom right. Top right would be bottom left. That's how this works. Go to your numbers. 110, 110. Who? I know, it's crazy. It's just that. Weird. Never would have guessed that numbers sometimes work. Okay. These guys again are also congruent. Okay. As we go through these things, I will show you guys a really, really nice trick as far as knowing how to set them up and how we're going to solve them through. That was 3 of them, right? Corresponding, alternate interior, alternate exterior. The only thing that's left is what they call same side, or same side interior. The last one is the same side interior. Gee, where do you think those are?
On the same side on the inside.
Right. Give me a numerical example here. Which ones? Oh, same side inside. Are 5 and 6 on this on the
Not on the same side.
inside?
5.
Yeah. Same side. Same side of transversal between the lines. This one's a little bit different. That's these two guys here, X and Y. They're not necessarily the same angle. When you look at our numerical value here, 110 and 70, those are same side inside. 110 and 70, those are same side inside. What do both of those same side inside angles? Yep. Same side interior or same side inside, or however they call it. These guys will always sub-measured. They will always add up to equal 180. That never changes. Just another pop quiz for you. Okay. These guys are always supplementary. And if you recall, one of the vocab that was on the quiz yesterday said angle 1 and angle 2 are dun, 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 supplementary. So that's what we worked with. So again, if I'm looking at our number stuff here, when your lines are parallel, same side interior are always going to be supplementary. Okay? They're always going to be supplementary. If you look at the degree symboled one that we put over here, how many different angles really are there? Just 2, right? There's just 2 different angles, 110 or a 70. So what happens here, guys, this is kind of the big part of this whole thing. As soon as your lines are parallel, every time you look at a problem, every time you have a solve for x, or you have an algebra portion of it, because that's kind of what we're working on here today, we do the same thing. We go to our top left corner, put a tick mark, and then where's its vertical? Where's the alternate interior? This, the right or the left? Left. Where's that vertical? Those 4 angles will always be the same. What about the other 4 angles? They're always going to be the same. Now, here's the thing. What I would do is, my handwriting isn't the greatest, if you haven't noticed, but what I normally do is, if I have angle parts that match up with those tick marks, they're always going to be equal. If one has a tick mark and one doesn't, they're always going to be supplementary. If both angles don't share a tick mark, like for example, if I'm here and here, they still share nothing, but they're still the same. I'm just not putting in that secondary line because it just gets messy. See what I mean? It just gets messy by putting it in. Okay. Which means we can do stuff that looks like, oops, sorry, got the wrong page up. Like this. looking too, but that's cool. Now, real fast here. Here's a real tough thing to consider. But you have to pace yourself here. Those lines don't look how we've done everything, do they?
No.
What would you do to your page?
Nothing. Turn the page.
Couldn't you just turn the page a little bit? Make it line up a little bit nicer? Twist your page around a little bit to line it up so that way you can still do the same thing. Everything that has a tick mark has to be equal. Everything that doesn't have the tick mark also has to be equal because the lines are parallel. So all the non-tick marked angles have to equal 95. The non-tick mark, I said. All the ones that are tick marked then would be 85. Very good. Okay. Just following tick marks to go through. Okay. Start talking about algebra. Okay. Flip over to the other side. Let's look at number 17 on the top. Yeah. 17 on the top. Football player of all time. Last example. This is 22 on the top. Same thing. I'm going to do this real quick. Watch your. What are we going to do when one of them has a tick mark and one of them doesn't? What does that always mean? Oh. What is it? Equal. What do you mean equal 20? Yeah, they equal 180. Yeah. They have to equal 180. Remember, if they don't share them, if you made the other track here going this way, you would have brought the 105 here, and these two are next to each other, creating a line. that means they have to be supplementary. So if one has the tick mark and one does not, they will always be supplementary. And you set it up that way. Finish that side, please. Yeah, the side we're on right now. Finish that side for this evening. We'll go and do some more of this stuff, and then yell it out. Okay? Should not take very long. One suggestion I would make is while we're sitting in here in class, make your tick markers on all the angles. That way you know when you get back to it in a little while, if they share a tick mark, they're equal. If they don't, or if they both don't share the same tick mark, they're equal. If one has a tick mark and one doesn't, then they're going to be supplementary. It works every time when they're parallel. Okay? Yeah, on the back. The 17 through 22 and the 17 through 22. Oh yeah, and the 22. Yeah, I put that one there.